Okay, another one. I went back to transient analysis using the values that we had come up with in the last video. I put this back to a sine wave, 10 volts peak, 100 hertz. This one is 15 volts peak, 350. Those aren't the values on the problem. Okay, that set that up. And there's my transient analysis, my step time, and sine wave, 5K, 15K, and I'm looking at the voltage over the 15K. Now, doing a little bit of analysis, I can see that my voltage level across the 15K from V1 will be 5K plus a little bit, and my voltage level from V2 across the 15K will be less than 5K or 10K, or less than a third of the 15 volts. So somewhere around 4, somewhere around 6 for the 10 volts, 6, 7, 8 for the 10 volts based on parallel circuits. That's if I do the superposition and remove V2 and just look at V1, the 10K, 15K going parallel. And if I remove the V1, then the 5K and the 15K are in parallel. And I can sort of guess what my voltages are. Now I'm going to go back over the spreadsheet, and I'm going to set up a waveform. I'm going to make it big. So there's my 100 hertz. There's my 350 hertz. And that gives me a waveform. On my 100 hertz, I'm going to say I've got about 7 volts dropped across that resistor, and again, that's just a guess. And on my 3 volts, or my 350 hertz source, V2, I'm thinking I get around 4 volts. My step time, max time per step, is 0.003, and we're going to use that when we build the spreadsheet. And we want to go around 2 cycles, or 0.002. So we want to start, we don't need the 15Ks, don't need any of the resistor values. So frequency, and I'm just going to add a row here because I like to label things so I know what's what. And this is the V1 frequency. This is the V1 amplitude, 7. And I'm going to use this equation, which is a pretty straightforward equation. V max is my V amplitude in this equation. They are the same thing. And it's 2 pi times frequency times time. That's a pretty common equation. It's easy to find. I'm going to label my V2 frequency, which is 350, and I'm going to put a label above my V2 amplitude, which I guess should be around right around 4 volts. We'll see how that turns out. My sample time and my total time. So I basically need to create a time column, and I'm going to start at 0, and I want to increment it by 0.0003 and go all the way to 0.02 seconds. Okay, there's different ways you can fill in a spreadsheet, and I'm just going down here Gonna look for fill and don't see it. So now I'm gonna go back up and see what else. Actually, a better way to do it is just populate the cell. I'm gonna look a minute to see if I can see the fill cells. I think it was under sheet and I missed it. I'm thinking it's maybe in data. No. Oh well, this is a better way to do it. I can take the cell above it, C2, and then I can add my step time to it. So I would type equals C2, which is the cell above, plus my step time, 0.0003. So that references the cell above, and my addition is the step time. Okay, I want to use the same step time every time, and if that changes, I've got it. So what I'm doing is I'm putting a $sign in there, and that makes it an absolute reference. So as I copy this down, it will always refer back to that cell with the 0.003 in it, because I put the $signs in front. So I copy down a little bit, and I only want to go to 0.02. So I got to see where it stops at, 0.02. And right there, and anything beyond that I don't care about, so I'm going to delete it just to make my spreadsheet a little easier to manage. So now I have time values between 0 and 0.002 and steps of 0.0003. I'm going to duplicate that column, and all I have to do here is just type in the cell reference. So this cell equals cell 2, and then if I copy this cell and go down, it's just going to copy all those C columns over into the F column, and I'm going to make them the same length. Control C, highlight what you want, and then Control V. Now I'm going to build my first voltage waveform, V1 and V2, and I'm going to go back and use this equation. Now I know my max, I know what my frequency is, and I know what my time is. My time is going to come out of that column. So my amplitude, my frequency, and my time are what I need. And I've got my amplitude, my frequency, and my time. So I can go over here, and there's my amplitude. So I can say equals my amplitude. I'm going to do an absolute reference. So it's going to be $B, $2 times sine, open parentheses, 2 times pi, pi, open close parentheses, that's how it's done in most spreadsheets, times frequency. I'm going to pull from A2, again I need the absolute reference, so $A, $2 times my time, and this one won't be an absolute because as I copy down I want to copy different values, so I just type in the C2 part, and then when I copy it down I'll have my waveform. Got to close my parentheses and hit enter, and there you go. Now 0, because the sign of 0 is 0, so that one's not very interesting. But as I copy CD2 in this case, and then I highlight and hit Control V, you see I get those voltage levels. I get instantaneous voltage levels at those times, and that's what we want to do. So I did it for V1, I'm going to do it for V2. What's different is my amplitude is different and my frequency is different. My time will be the same, and this also assumes these waveforms start at the same time, which is what happens in LT Spice. So amplitude is absolute reference to B4, $B, $4 times sine 2 times pi times frequency, which is $A, $4. Times, and then C2 again. I want to pick up that time column. Close parentheses, hit enter, sign of 0, 0 again. But I'm going to Control C that, highlight below, and Control V, paste. So now I have a V1 waveform and I have a V2 waveform. And now I want the combined waveform. And this is pretty easy because I'm just going to add my D column to my E column. So my D2 plus E2, we'll get those two on this row, and then I can copy. I'm going to label it combined. Then I can copy, Control C, and highlight. I'm clicking and dragging to highlight. Control V, and then I have my waveform. Now the reason I created the extra time column was for the graphing purposes. I won't like to have my X and my Y side by side, and I'm highlighting those two columns, all the values, and now I got to figure out how to graph. It's been a little while. There's a graph symbol right there. Let's see what we get. Ah, yes, chart type. Usually with chart type you want XY scatter, and you can then go in and you can set what you want, whether you want points, you want lines, whatever. I like to have smooth lines, and that looks pretty good. My data range, this is why I highlighted and copied, because it gets it, and it picked up my first row as a label, which was time and combined. And so it shows me my X values and my Y values, and I don't have to type them in. Much easier. And there is my waveform, and you can see that it has approximately the same form as what we had in LT Spice. There it is. Pretty much the same form. My values are a little off. I can go in and adjust them, but you see basically I got the same shape. And that's what LT Spice is doing. Like I said earlier, these are starting at the same frequency at the same point. But that's what I was referring to when I said for 12 and 13. And then graph it. So you're building it and you're graphing it. 12, 13, and 14. And you're going to compare the voltage graphed for the 15K to the voltage observed on the oscilloscope. They should be pretty close to the same, and real world symbols can be represented based on equations. Can Kirchhoff be used on the circuit instead of superposition? We use Kirchhoff analysis, but when we do superposition, we have to break it into two problems and then use the Kirchhoff analysis in order to solve it, if we don't use LT Spice to solve it for us. But Kirchhoff can only be used if all your voltage sources have the same frequency. If the frequency is different, I mean, even by as little as 0.001, then you will get the waveform like we graphed. It will not be a pure sine wave, at which point you have to go to superposition. So that is pretty much the end here, and I thank you for watching.